Hello viewers, you are welcome to my YouTube video. Today I'll be solving a problem on the topic statistics. In this problem, the question states the following amount of money were contributions made by 100 graduating students of a college to an orphanage. The first column contains the amount of money given by the students to the orphanage, which ranges from $1 to $100. Whereas the second column gave us the amount of students, or rather the number of students that gave the respective amount of money on the left hand side of the table. So we can see here 4 students gave $1 to $10, 5 students gave $11 to $20, 6 students gave $21 to $30, 9 students gave $31 to $40, 13 students gave $41 to $50, 17 students gave $51 to $60, 14 students gave $61 to $70, 16 students gave $71 to $80, and 10 students gave $81 to $90. Finally, 6 students gave $91 to $100. In this problem, I am requested to construct a histogram and then draw a frequency polygon on the histogram. Finally, the question requests that what percentage of the students gave $31 to $80 to the orphanage. Now, before I solve this problem, I would like to explain the reason why histogram is being used. By the way, histogram is one of the methods of representing data graphically. That was why this question requests that we should use histogram. Other methods that could be used in solving this problem, which is in the area of graphical representation of data in statistics, could be the use of the pie chart, the use of the bar charts, the use of the pictogram. These are some of the methods that could be used. But in this problem, I am requested to use the histogram to solve this grouped frequency distribution. So, to start solving this problem, I'll replicate the frequency table. This table, by the way, is called the frequency table, but I'll need to add more flesh to it. So I'll replicate the first column, signifying the amount of money which represents the contributions made by the students to the orphanage, and then the number of students that gave the contribution. So before I create a third column, I would like to explain some terms. The value I have here, 1 to 10, this one is known as the lower class limit of the first class, or simply put, lower limit of the first class. 10 here represents the upper limit of the first class, or the upper class limit of the first class. 11 represents the lower class limit of the second class. 20 signifies the upper class limit of the second class. 21 signifies the lower limit, or the lower class limit of the third class, and 31 signifies the upper class limit of the third class. And then we can go on and on until we get to the last value here. 91 signifies the lower class limit of the 10th class. 100 signifies the upper class limit of the 10th class. And then we have the number of students that gave the amount of money shown under the first column. So I'll create another column and I'll give it a name, class boundary, because histogram is a graph of frequency on the vertical axis and then the class boundary on the horizontal axis. But because the problem at hand uses amount, so we can rename our horizontal axis as amount rather than using class boundary. Okay, so for me to fill up my class boundary, we need to get the values or the answer from the first column, which is the column of the amounts, otherwise known as the class intervals, which signifies the range of values given by the students to the orphanage. For me to get the first value here for the class boundary, which is the lower class boundary of the first class, I need to work with the lower class limit, but this one is not sufficient. I need to find a midpoint between the lower class limit of the first class and then the upper class limit of a class that exists before this first class. So I need to assume the existence of a class before this first class. But before I make that assumption, I need to get the trend. Let's look at the trend in this question. The upper class limit of the first class is 10. the lower class limit of the second class is 11. When the upper class limit of the second class is 20, the lower class limit of the third class is 21. So looking at the trend, you agree with me that the lower class limit of successive class is 1 more than the upper class limit of the previous class. So you can see 10, 11, 20, 21, 30, 31, 40, 41, 50, 51, 60, 61, 70, 71, 80, 81, 90, 91, and then we have 100. So for us to be able to figure out the lower class boundary of the first class, we need to assume the existence of a value before the first class. So if we do, following this trend, since the upper class limit of a class is usually 1 less than the lower class limit of the next class, so if I have 1 here, if I assume that there's a class here, the upper class limit of that class will most likely be 0. So that we'll have 0, 1, 10, 11, 20, 21, 30, 31. This is consistent because we have the values following that trend. So to figure out this first value, I'll write out my 0, which is the upper class limit of the class that we assume is existing before the first class, plus the lower class limit of the first class, which is 1, divided by 2, and the answer is 0.5, and that will be my lower class boundary of the first class. Now to get the upper boundary of the first class and the lower boundary or lower class boundary of the second class, I need to find a midpoint between 10 and 11. So I'll clean this up and then I'll write 10, which is the upper class limit of the first class, plus 11, which is the lower class limit of the second class, divided by 2, which is equal to 21 divided by 2. This boils down to 10.5. So I'll write it as the upper class boundary of the first class and then the lower class boundary of the second class. I'll clean this up. To get the other one, I'll have to work with 20 and 21. So I'll write my 20 plus 21 divided by 2 equals 41 divided by 2. This boils down to 20.5. So over here I will have 20.5 to 20.5 and 20.5. 20.5 representing the upper class boundary of the second class and then the lower class boundary of the third class. So I'll clean this up. To get the upper class boundary of the third class and the lower class boundary of the fourth class, I'll work with 30 and 31. So I'll write my 30 plus 31 divided by 2 equals 61 divided by 2. If I divide this, it boils down to 30.5. So I'll write it here. So I've gotten my upper boundary of the third class and the lower boundary of the fourth class. So I'll clean this up, and then to get the next midpoint value, I'll pick 40 and 41. So 40 plus 41 divided by 2 equals 81 divided by 2, and this boils down to 40.5. So I'll write it here. So I've gotten the upper class boundary of the fourth class and then the lower class boundary of the fifth class. So I'll clean this up. To get the next values, I'll pick 50 and 51 and divide it by 2. To get a midpoint of 50 and 51 equals 101 divided by 2. This boils down to 50.5. So I'll write it here as the upper class boundary of the fifth class and the lower class boundary of the sixth class. So I'll clean this up. To get the next value, I'll work with 60 and 61. So I'll write out my 60, which is the upper class limit of this class, the sixth class, plus 61, the lower class limit of the seventh class, divided by 2 equals 121 divided by 2 equals 60.5. So I've gotten my upper class boundary of the sixth class and then the lower class boundary of the seventh class. So I'll clean this up. Now to figure out the seventh and the eighth class values for the upper class boundary and the lower class boundaries of the seventh and the eighth, or rather, yes, the upper class boundary of the seventh class and the lower class boundary of the eighth class, I will work with 70 and 71. So 70 plus 71 divided by 2 equals 141 divided by 2. This boils down to 70.5. So with what I have here, I'll write it here. And so I have my 70.5 as the upper class boundary of the 7th class, and the same value being the lower class boundary of the 8th class. So I'll clean this up to get the upper class boundary of the 8th class and the lower class boundary of the 9th class. I'll pick my 80 plus 81 divided by 2 equals 161 divided by 2. This boils down to 80.5. So I'll write it here and here. So I've gotten my upper class boundary of the 8th class and the lower class boundary of the 9th class. So I'll clean this up to get the next value. I'll work with 90 and 91. So 90 plus 91 divided by 2 equals 181 divided by 2. This boils down to 90.5. So I've gotten my upper class boundary of the 9th class and the lower class boundary of the 10th class. Now to get the upper class boundary of the 10th class, the way I assumed the existence of a class before the first class, I need to assume the existence of a class after the 10th class. So looking at the trend, since the lower class limit of a class is usually one more than the upper class limit of the previous class. For instance, if you look at this, when we had 80 as the upper class limit of the 8th class, what happens? We have 81 as the lower class limit of the 9th class, and then when we have 90 as the upper class limit of the 9th class, we have 91 as the lower class limit of the 10th class. So if we have 100, you agree with me that if we have another class here, the lower class limit of that class would most likely be 101. So I'll clean this up and then I'll pick 100 plus 101, which is the assumed value of the next class. And then we'll find a midpoint, which is equal to 201 divided by 2 equals 100.5. This is the midpoint of 100 and 101. And then we'll write it here as the upper class boundary of the last class. Take note, all the values here are called the upper class boundaries of their respective classes. You can simply put it as the upper boundary, whereas these are the lower class boundaries of the respective classes, which is the 1st, 2nd, 3rd, 4th up to the 10th class. And you can simply put it as the lower boundary of the respective classes we have from 1 to 10. Now that our frequency table is all set, we are good to go. Now we can plot our histogram. So I'll get my graph sheet. So from the graph sheet, you need to understand that in using the graph sheet, your graph must always occupy more than 2/3 of the entire space of your graph sheet. So don't plot your graph in a way that it will be very small. Make sure you occupy more than 2/3 of the graph sheet. So let me create my columns. I have the vertical axis, which signifies the number of students that gave the donation to the orphanage, whereas the horizontal axis, which will signify the class boundary, will be given the name amount, because that was what was given to us in the question. So I prefer to work with amount in dollars. So I will need to calibrate my vertical axis to suit the number of students that I have, which is equivalent to the frequency. The maximum value I have under the number of students here is 17, and the smallest number here is 4. So I have to pick values for the calibration of the vertical axis in ways that all these values will fit in properly. So for me to do that, I will give it 5 centimeters, 2 centimeters to 5 units. What do I mean by 2 centimeters? From this 0 mark to the first bold line is 1 centimeter approximately, and then from here to here is 2 centimeters. So I'm using 2 centimeters to 5 units. Now for me to be able to get every single value, I need to get the value of a small box, the smallest division. So for me to get the value of the smallest division, I need to ask myself, how many divisions do I have from 0 to 5? I have 10 divisions. Here to here we have 5, here to here 5. 5 plus 5 is 10. So I will say 5 divided by 10, meaning one small division will be 0.5. So if here is 0.5, if I move 2 steps, that will be equal to 1. 3 steps, 1.5. 4 steps, 2. 5 steps, 2.5. 6 steps, 3. And then we can go on and on until we get to the 10 steps, which is equivalent to 5. Now I'm done with my vertical axis. I'll move to the horizontal axis, which signifies the class boundary, but I gave it the name amount because of the value given to us in this question. What we're dealing with is the amount of money given by graduating students to an orphanage. So I'll calibrate my horizontal axis. So I'll prefer to use 1 centimeter. From here to here is 1 centimeter. 1 centimeter to represent 10 units. How did I arrive at that? Because if you look at our data, we have first class up to the 10th class. Now we need to know the class sizes of the various classes we have. Now, to get the class size, you have to find the difference between the upper class boundary of that class and the lower class boundary of the same class. So for the first class, 10.5 minus 0.5 is 10. So the class width or the class size of the first class is 10. The second class, 20.5 minus 10.5 is 10. So the class size of the second class is 10. And then if I move to the next class, the third class, 30.5 minus 20.5 is 10. So you can see it's same. 40.5 minus 30.5 is 10. And then we can go on and on. Each of the classes have the same class sizes. So the class width is the same. It's consistent all through. So I can make use of the class boundary. So the first value here signifies the lower class boundary of the first class. And then we can pick 10.5 for the next value. And then we can go on and on until we get to the upper class boundary of the last class, which is the 10th class, which is 100.5. Now, since I have all my values on the horizontal axis ably represented, and I have values on the vertical axis that could accommodate the maximum value I have, which is 17, then I can plot my histogram. The first bar, which is values from 1 to 10, represented by the class boundary 0.5 to 10.5, the amount of student that gave that amount of money in the question is 4. So I will stop somewhere here, right? So I have 4 for the first bar. The second bar is 5. So I'll stop around here if I plot the graph. The third bar is 6. So somewhere here. The next bar is 9. So I'll move to a value close to 10, 9. The next bar is 13. So I'll move to, this is 10, 11, 12, and then we'll have 13. The next bar is 17. So I'll move up till 15 here, 16, 17. So I'm done with that bar, and then I'll move to the next bar, which is 14. 14 will be 1 less than 15, somewhere here. The next bar is 16. So I have 15 here, 16 will be here. The next bar is 10. So I'll stop somewhere here, and then the final bar, I'll draw the final bar, which will stop at 6. So I'm done with my histogram, as you can see. So I'm done with the first part of the first question. The next part of the first question requests that I should construct a frequency polygon. Now, frequency polygon is a straight line joining the midpoint of the bars together. So I have about 10 bars here. So I'll join the midpoints together. But first, I'll draw the first midpoint. I'll join it to the midpoint of a bar that will have existed if there exists any bar before the first bar. So since there's no any bar before the first bar, the midpoint of this next value will be somewhere here. I will join it to this midpoint of the first bar. So I'll draw my first line. The green line signifies the line for the frequency polygon. So I'll join the midpoint to this midpoint, and then this midpoint to this midpoint. Take note, I'm using a straight line, a ruler, to join the midpoints together, not minding the direction of the movement, provided I'm joining the midpoints together. So I will join this midpoint to the previous one. This midpoint will be joined to this point, this midpoint to this, and then to this point. I will join it to this point, and then to this point, and then to this point. Now I'm almost through. The way I started it, I have to join this last midpoint to a point which will have been existing if there's another bar before that. Since there's no bar, it will just be the point on the horizontal axis. So I'll join it here. So with this, I'm all set, and then I have my frequency polygon, as you can see. Now the last part of the question states that what percentage of the students gave $31 to $80 to the orphanage. So to solve the last part of the question, I need to look at the number of students that gave from $31 to $80. Looking at the frequency table, $31 starts from 9, and then those that gave from $31 to $80 are 9 plus 13 plus 17 plus 14 plus 16. So I'll write the sum of those that gave the amount of money from 31 to $80. So I have 9, which is the first value, then plus 13, and then I'll say plus 17, plus 14, plus 16, which is the last value from 31. Take note, from 31 to 80. That was what was requested in the second part of the question. And then I'll sum this up, and this boils down to $69. Therefore, the percentage of students that gave from $31 to $80 are 69 divided by the total number of students that contributed towards the support to the orphanage. So if you look at the summation, the question gave us 100 students, right? Multiply by 100%, since we are dealing with percentage. So 100 divided by 100 is 1. And then 1 times 69 equals 69%. So we're done with the problem at hand. We'll be able to get the histogram, the frequency polygon, and the percentage number of students that give from 31 to $80 to the orphanage. I do hope you understood every bit of the solution of today. Kindly like my YouTube videos. I have some other YouTube videos. I will appreciate if you like and drop your comment at the comment section. And if you have not, kindly share it with your friends, and will appreciate your subscribing to my YouTube channel, which is Victoin STEM. I sincerely appreciate your watching and following the solutions that I've been providing on my YouTube channel. Thank you.